Hi everyone, I just wanted to make a video about what we looked at today in class, which is polynomials that are bigger and more complicated than quadratics. The reason I wanted to make the video is for anyone who missed it or for anyone who wants to revise this later on. So up until now, we've been looking at equations that look something like this. So y equals ax squared plus bx plus c. And we call those quadratics. And we've also in the past looked at equations that look something like this, y equals ax plus b. And we call those linear equations. There are also equations that get more complicated than that. So for example, I'm sure you would have seen these before. If we went ax cubed plus bx squared plus cx plus d, that's actually what we call a cubic function. And we can even go to y equals ax4 plus bx cubed plus cx squared plus dx plus e. And one of those guys is called a quartic. And we can actually get even bigger and bigger functions than that. There's actually no limit. We could have something ax to the power of 15. There's nothing stopping us from doing that. All of these functions are what we call polynomials. So they're all in the class of functions called polynomials because they have x in them as a variable, and the exponents of x are integer values. So we don't have x raised to the power of a half. They're also positive integers, so we don't have x to the power of -2. They're always positive integers. So that's what makes these polynomials. Now, there's a few things that we can look at in these polynomials, which I guess we can use to compare between them or just talk about the polynomial, the characteristics of the polynomial. So there's a few words that come along with that. First of all, these numbers that are in front of the x, and I made a mistake there because I highlighted b up there. I should have just highlighted the numbers in front of the x values. These numbers are what we call coefficients. Okay, so I've done those in orange and I've written the word coefficients in orange. So the coefficients are the numbers in front of those x values. In particular, we're often interested in the coefficient of the highest power of x. So in this case, this is what I've called a. Okay, so notice that a is in front of the highest index of x. So here it's in front of ax to the 4. Here it's in front of ax squared. This number here is what we call the leading coefficient because it's at the front and it's leading the way. Okay. On a similar note, we're also interested in the biggest number, the biggest index of x. Here is actually a 1 that we can't see. We don't normally write the 1. We're interested in this because it tells us how complicated the polynomial is and what it's going to look like. This number tells us what we call the degree of the polynomial, and you'll notice that these just go up by 1. So a linear equation has a degree of 1, quadratic degree 2, cubic degree 3, quartic 4, and so on. The last thing that's often interesting to us as well, and I'll just get one more color for that, is the number that's on the end that isn't associated with any x value. These numbers here are called the constant. So the constant is called the constant because no matter what x is, this term on the end of the equation is always the same. So we call it the constant. Okay, so you might be asked some things about polynomials, and these are the things that you would normally be asked. And in fact, if you do exercise A in the work booklet that I've given you, it will be asking about all of these things. Now, one thing just to be wary of is that sometimes, like I've written all of these in a really nice order. So I've started with the biggest exponent and then I've gotten smaller from there. Sometimes they're not going to be necessarily written in that order. So if we had, 5x take 6 plus 10x squared plus 2x cubed, well, that's not in the same order as this. And so if you were asked what the leading coefficient is, it's not 5. 5 is the coefficient of x. It's not the leading coefficient. You've actually got to rearrange it so that they're in order first. So I would actually put the 2x cubed first, then the 10x squared, then the 5x, and then the take 6. And then if I was asked what the leading coefficient is, it would be 2 in that case. So just something small to be aware of there. The other thing that we might be interested in is having a look at whether two polynomial equations are equal. So I'll write the definition for equality here. So two polynomials are equal if and only if the degree is the same and the coefficient of each term, the coefficients of each term are the same. Okay, it seems fairly obvious. Let me just show you a little example of why you might need to know this. Let's say that we had a polynomial 5x cubed plus 2x squared take x plus 3. And we said that was equal to bx cubed plus 2x squared plus ax plus 3. And we wanted to know what are a and b. Well, if these two are equal, then the coefficients have to correspond to each other. So the correspondent of x cubed has to be the correspondent of x cubed on the right hand side. The coefficient of x squared has to be the same on the right hand side, and we can see that it is. The coefficient of x squared on the left has to be the same as the right, and the constants have to be the same as well. So I should add another criteria here. Constants have to be the same as well. The constants are the same. So if we come back to our example, well, b has to equal 5 because the polynomials are equal, and a has to equal -1. So seems fairly simple and fairly obvious, but it's worth just spelling that out explicitly because there might be some slightly trickier problems that involve this idea that you come across. Okay, that's all I want to go through in this video. Thank you for watching.